Imagine this. What if Earth was the most primitive planet, the most technologically and evolutionarily backward in the entire universe? This idea can be disconcerting, but it also forces us to look beyond our borders and question our position in the cosmos. As we struggle with wars, climate change, social divisions, and challenges that seem insurmountable, other civilizations may be advancing at levels we can barely imagine, exploring parallel dimensions, manipulating space-time, or even creating new universes. As we struggle with wars, climate change, and social divisions, other civilizations may be exploring parallel dimensions or creating new universes. Imagine species that have transcended their physical bodies, transforming into purely digital or energetic forms. For them, concepts such as scarcity, conflict, or even death may be completely irrelevant. These civilizations could be watching our planet like a cosmic laboratory, waiting to see whether we can overcome our own challenges or whether we will succumb to the same forces that have destroyed other, less adapted species. Today we'll explore this disturbing idea that puts humanity into perspective and could change your view of our place in the cosmos. Are we really a special species, destined to conquer the stars, or just one of billions of failed attempts at intelligent evolution? This question is not just philosophical, it has profound implications for how we approach our future as a species. If we are the laggards of the universe, that means we still have a lot to learn, and perhaps little time to do it. This theory also leads us to rethink what it means to be advanced. Advancement is not just about technology or science, it's about how a civilization deals with its internal challenges, such as sustainability, cooperation, and harmony with the environment. Perhaps we are so focused on competing with each other that we neglect the true goal of evolution, creating a balance that allows us to thrive both individually and collectively. What if other species already understood this millennia ago? The Earth is just a small blue dot among billions of galaxies, but are we unique or totally common? This question has echoed for centuries, but it has never been more relevant than now, when our technology finally allows us to glimpse worlds other than our own. With each new discovery of exoplanets, planets that orbit stars outside our solar system, we get closer to answering whether Earth is special or just one of many habitable worlds scattered across the cosmos. To date, astronomers have identified thousands of exoplanets, some located in the so-called habitable zone, the region around a star where conditions can allow the existence of liquid water, an essential ingredient for life as we know it. Some of these planets are very similar to Earth in size and composition, while others have strange and exotic features, such as methane-rich atmospheres or ice-covered oceans. However, we have not yet found clear evidence of life in any of them. Does this mean we are special? Or are we simply in the early stages of a search that could take centuries? On the other hand, the vastness of the universe suggests that we are probably ordinary. After all, with billions of galaxies, each containing billions of stars and planets, it would be unlikely that Earth would be the only place where life emerged. What would make us truly special would be the level of technological and cultural development we have achieved, or on the contrary, our apparent lack of progress compared to other civilizations. What if there are planets with billions more years of evolutionary history? These worlds could harbor life forms that transcend anything we can imagine, from super-advanced artificial intelligences to species that have mastered the manipulation of matter and energy. Are we at the tail end of cosmic evolution? This possibility is both humbling and motivating. If we are one of the youngest and least developed civilizations in the universe, that means we have a lot to learn. Perhaps we are just in our infancy in terms of scientific, technological, and even spiritual understanding. More advanced civilizations may have solved problems that still seem insurmountable to us, such as interstellar travel, infinite energy sources, or the unification of individual consciousnesses into a collective mind. To them, our wars, inequalities, and environmental crises may seem primitive and unnecessary, but being ordinary doesn't have to be a negative thing. On the contrary, it could be an opportunity. If Earth is just a typical example of a habitable planet, that means other civilizations have likely faced challenges similar to ours. How did they manage to overcome these obstacles? What lessons can we draw from their experiences? This perspective offers us hope. Perhaps the path to advancement is within our reach, if only we choose to follow it. This reflection also forces us to consider the concept of cosmic time. Joyce, and While we measure our existence in years or centuries, the universe operates on timescales that are incomprehensible to us. A civilization that emerged millions of years ago may be so far ahead of us that their presence is undetectable, or perhaps they have chosen to remain silent, observing our progress, or lack thereof, from afar. The Kardashev Scale classifies civilizations based on their energy use. We are barely out of type 0, nor do we control all the energy on our own planet. This scale, proposed by astrophysicist Nikolai Kardashev in the 1960s, measures the technological progress of a civilization by the amount of energy it is capable of collecting and using. Type 1 civilizations dominate all available energy on the planet where they live. Type 2 are able to harness all the energy of their parent star, and Type 3 control the energy of an entire galaxy. And us? We are stuck at an early stage, still struggling to manage Earth's limited resources without causing environmental collapse. Humanity is currently classified as approximately type 0.7, meaning we only use a fraction of the total energy available on the planet. To reach type 1, we would need to learn how to capture and distribute all the solar energy that reaches the Earth, in addition to eliminating waste and conflicts over resources. This may seem ambitious, but not impossible. However, reaching type 1-2, where we can build structures like Dyson spheres around the Sun to harness its energy, seems thousands of years away, if we ever get there. Type 3 is something we can barely imagine. Civilizations capable of manipulating the energy of billions of stars in an entire galaxy. What if these civilizations existed millions of years ago? What would they be doing now? Imagine species that transcend our basic understanding of physics and biology. A Type 2 civilization could be exploring neighboring solar systems, creating artificial habitats, or even modifying entire planets to make them habitable, a process known as terraforming. A Type 3 civilization could be performing even more impressive feats, such as traveling between galaxies, manipulating black holes, or creating artificial universes within cosmic laboratories. For them, concepts such as time and space can be completely malleable. But why haven't we found clear evidence of these advanced civilizations yet? Perhaps they are so far ahead of us that their activities are undetectable to our primitive technology. Or perhaps they chose to remain invisible, either as a precaution or because they consider interstellar communication irrelevant. Another intriguing possibility is that these species have already abandoned physical bodies, transforming into purely digital or energetic forms, free from the material limitations that still bind us. This perspective also forces us to rethink our priorities as a species. If we are so backward on the Kardashev scale, are we focusing our efforts in the right areas? Instead of spending resources on wars, rampant exploration, and excessive consumption, we should be investing in science, education, and sustainability to accelerate our technological progress. Every step we take toward Type 1 can bring us closer to fundamental answers about the cosmos and our place in it. Furthermore, this reflection leads us to consider the impact of our current behavior. If we continue destroying our planet and ignoring signs of global crises like climate change and social inequality, we may never reach the next level on the scale. Civilizations that cannot overcome their own internal challenges are likely to self-destruct before reaching Type 1. Are we destined to repeat this pattern, or can we change our course? While we struggle to understand basic AI, advanced civilizations may be creating simulated realities, traveling through time, or manipulating matter and energy at unimaginable levels. These superior species, which have reached advanced stages on the Kardashev scale, have likely mastered technologies that transcend our current understanding. For them, concepts such as artificial intelligence, biotechnology, and quantum physics may be as basic as electricity is for us. But what exactly could these civilizations be doing with all this knowledge? Imagine a Type 3 civilization that controls the energy of an entire galaxy. They could be using this energy to create artificial universes, as if they were laboratories where they test different physical laws or evolutionary scenarios. Another possibility is that they have developed simulations so advanced that they can live inside them, abandoning physical bodies and existing only as immortal digital entities. In that case, your entire civilization could operate in a cosmic metaverse, free from the limitations of space-time. But there is also the hypothesis that these civilizations have already mastered the manipulation of matter and energy on a subatomic scale. This would mean that they can transform any material into useful resources, completely eliminating problems such as scarcity or pollution. Perhaps they will even be able to alter the very structure of the universe, bending space and time to achieve instantaneous travel between distant points. To us, this would seem like magic, but to them it would just be a practical application of extremely advanced scientific principles. Have they already observed us and decided that it is not worth interacting with us? This idea, known as the zoo hypothesis, suggests that advanced extraterrestrial civilizations are aware of our existence, but choose to isolate us while we are still primitive. It could be a question of ethics. Perhaps they consider premature intervention to be detrimental to our natural development. Or it could simply be contempt. For civilizations that already dominate galaxies, watching humans can be like watching ants building colonies. It is not worth interrupting your activity unless something exceptional happens. Another intriguing possibility is that these civilizations are carrying out large-scale scientific experiments, using planets as natural laboratories. Earth could be one such experiment, closely monitored by alien observers who study how species evolve, interact, and solve, or fail to solve, their own challenges. If true, this would explain why we face global crises like climate change and war. Perhaps we are part of a test to see if we can overcome our limitations before we are considered worthy of contact. This perspective also raises questions about what happens when civilizations reach the pinnacle of their development. Some theories suggest that advanced species may eventually transcend the physical universe, migrating to parallel dimensions or states of pure consciousness. In this case, our search for signs of extraterrestrial life through telescopes and probes may be futile, as these civilizations have already abandoned detectable forms of existence. For them, the visible universe may be just a distant memory, just like the cradle for an adult. Ultimately, this reflection forces us to consider the impact of our own behavior. If we want to one day reach the level of these advanced civilizations, we need to rethink our relationship with the planet and with each other. Internal conflicts, environmental destruction, and lack of global cooperation are obstacles that keep us trapped in a primitive state. Are we destined to remain behind in the cosmos, or can we change our course and accelerate our progress? What if aliens see us as animals in a cosmic zoo, observing us, but without interfering, to preserve our natural development? This idea, known as the cosmic zoo hypothesis, suggests that advanced extraterrestrial civilizations are aware of our existence, but choose not to contact us. Perhaps they see us as a developing species whose evolution must occur without external intervention, like scientists who observe an isolated culture to study its progress without contaminating its customs. Imagine that these civilizations had established strict rules about how to interact with less advanced species. For them, humanity may be like a child learning to walk, full of potential, but still too fragile and immature to deal with the complexities of cosmic life. Their decision to isolate us could be motivated by a desire to protect us, or simply by a lack of interest in a species that still struggles with problems as basic as war, inequality, and environmental destruction. But is our invisibility a sign of protection, or indifference? On the one hand, this approach can be seen as a form of respect. If these civilizations have experienced the same challenges we face today, perhaps they understand that overcoming them is an essential part of the growth of any intelligent species. Interfering with our progress could be seen as harmful, like giving all the answers to a student before they have a chance to learn for themselves. In this scenario, our invisibility would be a blessing, allowing us to carve our own path in the cosmos. On the other hand, there is the more uncomfortable possibility that our insignificance is the reason for their indifference. Leng Mo. To civilizations that control entire galaxies or manipulate parallel dimensions, humanity may seem irrelevant, like ants to a human architect. They may observe us occasionally, but they see no reason to spend resources or energy trying to communicate with us. After all, what would a species still trapped in the exploitation of fossil fuels and divided by artificial borders have to offer a civilization that already dominates space-time? This hypothesis also raises profound ethical questions. If aliens are watching us, What is the limit between protection and paternalism? Do they have the right to decide our fate without consulting us? Or are we being purposefully kept in ignorance to prevent us from causing further harm to the universe? Worse still, what if they are using us as part of a larger experiment, testing how we react to global crises or even influencing our decisions without us realizing it? Furthermore, this theory forces us to rethink our search for extraterrestrial life. If aliens deliberately hide their presence, our efforts to detect them may be in vain. This would explain why, despite decades of research and programs like SETI, Search for Extraterrestrial Intelligence, we have still not found clear evidence of alien life. Perhaps we are looking in the wrong place, or using inappropriate methods to detect civilizations that operate at technological levels incomprehensible to us. However, this idea also offers us an opportunity for reflection. If we are truly animals in a cosmic zoo, that means we still have a lot to learn and achieve. Instead of waiting for alien saviors, we must take responsibility for our own future. Every step we take towards sustainability, global cooperation, and scientific advancement brings us closer to reaching the next level of the Kardashev Scale. And perhaps, one day, we will deserve the right to break out of our cosmic cage. The Fermi Paradox asks, if the universe is full of life, why haven't we found evidence yet? This question, formulated by physicist Enrico Fermi in the middle of the 20th century, continues to intrigue scientists and space enthusiasts. With billions of galaxies, each containing billions of potentially habitable stars and planets, it is statistically unlikely that Earth is the only place where intelligent life has emerged. So where are all the aliens? Why does the universe seem so silent? Maybe we're not ready to reach out. If we consider the vast technological difference between us and advanced civilizations, it makes sense that they may be avoiding direct communication until we reach a certain level of maturity. For these species, trying to communicate with humans can be like trying to teach quantum physics to a child who has barely learned to count. They may be waiting for us to solve our own problems, like wars, inequalities, and environmental crises, before they consider us worthy of interaction. But there is another, equally intriguing possibility. What if we already receive signals, but we don't know how to interpret them? After all, our understanding of extraterrestrial communication is limited by our own human perspective. Advanced civilizations may use communication methods that are beyond our current ability to detect or understand. For example, they could transmit messages through gravitational waves, neutrinos, or even manipulations in the fabric of space-time itself. To us, these signals could appear to be random noise or natural phenomena, when in fact they are deliberate attempts at communication. Furthermore, our current technology may simply be inadequate for detecting extraterrestrial signals. Equipment such as radio telescopes and space probes are designed to look for specific patterns of energy or radiation, based on assumptions about how other civilizations could communicate. But what if these assumptions are wrong? What if aliens use forms of communication that we can't even imagine? In this case, we are effectively looking for needles in a cosmic haystack without knowing exactly what we are looking for. This silence can also be explained by the concept of cosmic time. Civilizations in the universe can arise and disappear on timescales completely different from ours. An advanced species may have existed millions of years ago and left behind only undetectable traces. Or perhaps we have not yet reached the exact moment when our paths will cross in cosmic time. The universe is vast and ancient, and our brief existence as a technological species may be just a blink of an eye in its history. Another grim hypothesis is that most civilizations self-destruct before reaching an advanced stage. If this is true, then the silence of the universe would be a reflection of a common destiny. Species that cannot overcome their own internal challenges end up becoming extinct before becoming capable of exploring the stars. This leads us to an uncomfortable reflection. Are we destined to follow the same path? Or can we learn from the mistakes of past civilizations and avoid this fate? Finally, this lack of contact may be intentional and even beneficial. Perhaps advanced civilizations know something that we still don't understand, that premature contact between species at different stages of development can be dangerous. Interfering with our progress could cause social, cultural chaos, or even technological collapse. In this scenario, the silence of the universe would be a form of protection, allowing us to continue to evolve without external influences that could destabilize us. Advanced civilizations may have integrated biology and technology, creating hybrid life forms. This fusion between organic and artificial could be the key to overcoming the limitations imposed by natural evolution. As we grapple with ethical and philosophical questions about the use of cybernetic implants or artificial intelligence, more developed species may have already completely transcended their original physical forms, transforming into entities that combine the best of both worlds, biological adaptability and technological efficiency. We still hesitate to adopt technologies that can expand our physical or cognitive capabilities, fearing loss of identity or control. For many, the idea of integrating chips into the brain, replacing organs with synthetic versions, or even transferring consciousness to a machine seems dystopian or threatening. However, Type 2 or 3 civilizations would likely view these advances not as threats, but as inevitable steps in the evolution of intelligent life. For them, the separation between biological and technological may be irrelevant, a barrier that was overcome millennia ago. Do we need to abandon our fitness to reach the next level? This is one of the most provocative questions when we think about the future of humanity. Advanced civilizations may have realized that biological bodies are inefficient at surviving in hostile environments in the cosmos, such as planets without atmospheres or regions with intense radiation. By replacing parts or even the entire physical body with technological components, they could explore the universe without the limitations imposed by human frailty. Some theories suggest that these species may have completely abandoned physical matter, existing only as digital or energetic consciousnesses, free from the constraints of space and time. But this transition would not be easy, neither for us nor for other species. Perhaps resistance to technological DNA is a natural phase in the development of any intelligent civilization. Just as we face ethical dilemmas about AI, genetic manipulation, and automation, other species must also have gone through similar debates before deciding to embark on this journey of transformation. The challenge for us is to overcome our fears and prejudices, recognizing that the fusion of human and machine may be the only way to ensure our long-term survival. Furthermore, this integration can open doors to extraordinary achievements. Imagine a humanity capable of connecting minds directly to the internet, sharing knowledge instantly, or even forming a global collective consciousness. We could solve complex problems, like climate change and disease, with efficiency never seen before. And if we expand further, we could become part of a galactic network of consciousnesses, interacting with other civilizations and learning from their millions or billions of years of experience. However, this transformation also brings significant risks. If poorly managed, the fusion between biology and technology can exacerbate inequalities, create social classes based on bodily upgrades, or even result in loss of control over autonomous systems. Furthermore, there is the philosophical question. When we abandon our physical form, are we still human? Or are we sacrificing our essence in the name of progress? Ultimately, this reflection forces us to consider our place in the cosmos. If advanced civilizations have already transcended their biological bodies, this means that our reluctance to follow the same path keeps us stuck at a lower stage of evolution. But perhaps this delay is necessary, a pause to reflect on who we are and what we want to be before we embark on an irreversible transformation. The universe is billions of years old. Advanced civilizations may have emerged millions of years ago, leaving us behind. This perspective puts us in our place. We are newcomers in an ancient and vast cosmos, where other species have had much more time to evolve, prosper, and perhaps even disappear. The concept of cosmic time, a scale so immense that it makes our millennia insignificant, is fundamental to understanding why humanity appears so far behind compared to the potential for intelligent life in the universe. The Earth is approximately 4.5 billion years old, but human civilization as we know it has only existed for around 10,000 years. This means that we occupy an infinitesimal fraction of the planet's history, and even less of the history of the universe. Meanwhile, other species on older planets may have had millions or even billions of years to develop technologies and cultures incomprehensible to us. To them, our technological age may seem as primitive as the first stone tools seem to us today. But are we just getting started? Or have we already missed the bus? On the one hand, our short existence as a technological species suggests that we are only in our infancy on the cosmic journey. If we compare our trajectory to that of other civilizations, we are still in the initial phase of exploration and discovery. Perhaps we are one of the many species that will eventually reach the advanced stages of the Kardashev Scale, conquering the stars and harnessing unimaginable energies. In this scenario, our delay is not a reason to despair, but rather an opportunity to learn from the past and build a better future. On the other hand, there is the uncomfortable possibility that we have already missed the bus. Civilizations that emerged millions of years before us may have reached the peak of their evolution and disappeared, either through self-destruction or through transcendence into forms of existence that we cannot detect. If this is true, then the silence of the universe could be a reflection of an inevitable cycle. Species are born, grow, and eventually become extinct before being able to meaningfully interact with other forms of intelligent life. Are we destined to repeat this pattern? Furthermore, cosmic time also forces us to rethink our search for contact. Even though advanced civilizations still exist, their life cycles can be completely misaligned with ours. A species that flourished millions of years ago may have left behind only undetectable ruins or artifacts, or perhaps we are trying to communicate with civilizations that have not yet even emerged, species whose parent stars are still forming as we struggle to break out of our own technological cradle. This reflection also raises questions about the future of humanity. If cosmic time is so vast, are we in too much of a rush to find answers? Perhaps our obsession with immediate results is blinding us to the patience needed to explore the universe. We need to accept that evolution, both biological and technological, is a slow and gradual process. Every little advance we make, from creating more powerful telescopes to developing advanced AI, brings us closer to a greater understanding of the cosmos. However, this perspective also offers us hope. We are living in a unique moment in human history, where we finally have the means to begin answering fundamental questions about our place in the universe. Even if we are backward in cosmic terms, we still have the potential to achieve great things. Every scientific discovery, every technological advance, and every effort to overcome our own internal challenges brings us closer to the next level of evolution. What if Earth was an experiment created by advanced aliens to study primitive life forms? This idea completely challenges our worldview, suggesting that our existence is not the result of chance, but part of a carefully designed plan. Perhaps extraterrestrial civilizations have seeded life on our planet, or even manipulated our genes and ecosystems to observe how we have evolved over millions of years. If true, then every aspect of our history, from the emergence of life to modern conflicts, could be part of a cosmic experiment. Imagine that Type 3 aliens, with the ability to manipulate entire galaxies, decided to use planets as natural laboratories to test different evolutionary scenarios. Earth could be just one of billions of experiments, each with unique conditions: atmosphere, gravity, temperature, and even natural catastrophes scheduled to occur at specific times. In this context, our fight to survive climate change, wars, and pandemics may be less about bad luck and more about intentional design. Are our challenges and achievements planned tests? This hypothesis raises profound questions about the purpose of our journey as a species. What if every obstacle we face, from prehistoric mass extinctions to the ethical dilemmas of artificial intelligence, was a way to assess our resilience, creativity, and ability to cooperate? Advanced civilizations may be observing how we deal with these challenges to determine whether we are worthy of joining the cosmic club of technologically mature species. Or perhaps they are simply collecting data to better understand evolutionary processes in different environments. This theory also forces us to rethink mysterious historical events. For example, ancient myths about gods who taught humanity advanced skills may be records of direct alien interventions. Unexplained phenomena, such as unidentified flying objects, UFOs, or even seemingly sudden scientific advances, could be indications that these entities are adjusting their experiment over time. Could it be that certain global events, such as industrial revolutions or technological discoveries, were deliberately induced to drive our evolution? But what would be the ultimate goal of this experiment? Maybe it's something as simple as understanding the limits of intelligent life in different conditions, or something more complex, like determining which species have the potential to become intergalactic civilizations. Some theories suggest that when we reach a certain level of development, such as biotechnological fusion or the ability to travel between stars, we will finally be recognized by our creators. This would explain why we have not yet found clear evidence of extraterrestrial life. We are being monitored, but we have not yet reached the point of approval. However, this perspective also has uncomfortable implications. What if we fail this experiment? Could our self-destruction, whether by nuclear war, environmental collapse, or other catastrophe, just be an expected outcome in a cosmic laboratory? Or would aliens intervene if they realized we were about to compromise the experiment? These questions lead us to reflect on the responsibility we carry as a species. Every decision we make may be being evaluated by unseen observers, and our choices may determine whether we will continue to exist or be abandoned as a failed experiment. On the other hand, this idea also offers a new perspective on our achievements. Perhaps every scientific advance, every work of art, and every act of compassion is proof that we are progressing in the experiment. Advanced civilizations may be rooting for us, hoping we will overcome our limitations and reach our full potential. In this case, our mission is clear: to continue evolving, learning, and building a future that demonstrates our ability to coexist with the cosmos. Despite our delay, there is still hope. Even though humanity is just beginning its cosmic journey, we have the potential to reach extraordinary levels of development. The key is recognizing our current limitations and turning them into opportunities for growth. If advanced civilizations could overcome challenges similar to those we face today, why couldn't we do the same? Will we be able to reach advanced civilizations before it is too late? This question echoes urgently. The universe waits for no one, and if we want to participate in the galactic community, we need to act now. Our first step is to solve the problems that keep us stuck in the primitive stage: internal conflicts, unsustainable exploitation of resources, and lack of global cooperation. Type 2 or 3 civilizations would probably only interact with us if they realized that we were capable of contributing positively to the cosmos. This means we need to demonstrate maturity, both technological and ethical. What would be the next step for humanity? A clear path is to invest massively in science and technology, especially in areas such as clean energy, artificial intelligence, and space exploration. We need to master sustainable energy sources, such as nuclear fusion, or even capturing solar energy directly from space, to ensure we have the resources needed to expand our presence beyond Earth. Furthermore, we must prioritize the colonization of other planets and moons, creating habitats that allow us to survive outside our home planet. This will not only increase our chances of survival, but also put us on the cosmic map as a species that is ready to explore the stars. But technological progress is not enough. We also need to evolve spiritually and culturally. Human history is full of examples of how greed, selfishness, and division have prevented us from reaching our full potential. To reach advanced civilizations, we need to transcend these barriers, adopting values of cooperation, empathy, and respect for the cosmos. Perhaps the true test for our species is not building incredible machines, but creating a harmonious global society that reflects our ability to care for each other and the universe around us. Another crucial step is to broaden our search for extraterrestrial life. Instead of limiting our efforts to traditional methods like searching for radio signals, we should explore new forms of communication like gravitational waves, neutrinos, or even mathematical patterns hidden in the fabric of space-time. By expanding our understanding of what constitutes an alien signal, we increase our chances of finding evidence of other civilizations. Furthermore, we must be prepared to accept that we may have already received signals, but we do not yet know how to interpret them. This journey also requires us to rethink our relationship with cosmic time. Advanced civilizations probably see the universe on much longer timescales than we do. Instead of looking for immediate results, we need to learn to be patient and persistent. Every small advance we make, from creating new technologies to resolving global conflicts, brings us closer to the next level of evolution. And who knows, perhaps in a few hundred or thousands of years, we will be ready to come into contact with civilizations that currently seem unattainable. However, This optimistic view comes with a caveat. If we don't act responsibly, we run the risk of self-destruction before we reach that bright future. Civilizations that failed to overcome their own challenges likely disappeared without a trace. We cannot repeat this fate. We need to use our knowledge and resources consciously, ensuring that every step we take is towards sustainability and collective progress. Ultimately, this reflection leads us to an inspiring conclusion. The future is not written. Despite our backwardness, we have the power to shape our destiny. Every choice we make, from environmental policies to investments in education and science, can determine whether we remain confined to Earth or expand our horizons to the stars. We are faced with a unique opportunity to transform our backwardness into a springboard for the future. Before we reach the next level, we face imminent dangers: nuclear wars, runaway artificial intelligence, environmental collapse. These risks are not just theoretical, they are present in our daily lives, threatening our survival as a species. Despite our technological and scientific advances, we still carry the same flaws that have accompanied us since the beginning of civilization: greed, selfishness, and a lack of long-term vision. What if our immaturity, combined with the destructive power of our own creations, leads us to collapse before we can reach the stars? The history of humanity is marked by a worrying pattern. The more powerful we become, the greater the potential to cause irreparable damage. For example, the invention of nuclear energy brought both benefits, such as clean energy sources, and the constant threat of global annihilation. Likewise, artificial intelligence, which promises to revolutionize areas such as medicine and transportation, can also escape our control, becoming an autonomous force that prioritizes its own objectives over ours. We are racing against time to ensure these technologies are used responsibly. But are we prepared to deal with the consequences? Will our own immaturity condemn us to failure? This is perhaps the biggest risk we face. Advanced civilizations probably overcame their own internal crises before reaching higher stages of development. However, we are still struggling with basic issues such as social divisions, unsustainable exploitation of resources, and lack of global cooperation. These problems not only prevent us from progressing, they also increase the risk of self-destruction. If we continue to prioritize individual or national interests, rather than embracing a collective vision for the future, we may permanently jeopardize our chance to evolve. Furthermore, environmental collapse is an existential threat that we cannot ignore. Climate change, deforestation, and pollution are transforming our planet into an increasingly hostile place for human life. As we discuss political and economic solutions, the impacts of these crises are already being felt around the world: extreme weather events, water shortages, and mass migrations. If we don't act quickly to mitigate this damage, we could lose the only secure base we have to continue our cosmic journey. Another significant risk is the lack of ethics in technological development. The race to master new technologies, such as gene editing or autonomous weapons, often ignores the moral and long-term implications. For example, manipulating human DNA can bring cures to devastating diseases, but it can also create profound inequalities between those who have access to these modifications and those who do not. Similarly, the militarization of artificial intelligence could result in automated global conflicts, where life and death decisions are made by machines without human oversight. These scenarios are not just dystopian, they are real possibilities if we do not adequately regulate our innovations. However, recognizing these risks is the first step to mitigating them. We need to take a balanced approach to progress, prioritizing security and sustainability over unbridled growth. This means investing in education and global awareness, ensuring everyone understands the impacts of our technological and environmental choices. We also need to strengthen international institutions that can mediate conflicts and promote collaboration between nations, reducing the risk of wars and destructive competitions. Finally, this reflection leads us to a fundamental question: are we capable of learning from our mistakes? Perhaps the greatest test for humanity is not technological, but moral. To reach the next level of evolution, we need to demonstrate that we are trustworthy, both to ourselves and to any alien civilization that may be watching. Every decision we make today shapes the future we inherit tomorrow. We are facing a crossroads. Use our knowledge to build a better world or repeat the same mistakes that brought us here. The idea that we are the most backward planet in the universe may seem humbling, but it can also be a call to action. Recognizing our position in the cosmos does not need to be a reason for despair or resignation. On the contrary, this insight can inspire us to act with urgency and purpose. If advanced civilizations could overcome challenges similar to those we face today, why couldn't we do the same? The difference is in how we choose to respond to our delay, whether as a permanent limitation or as an opportunity to evolve. This chapter concludes with a powerful question. Should we accept our current position or strive to reach our full potential? Accepting our current position would mean recognizing our flaws and limitations, but also being content with the status quo. On the other hand, striving to reach our full potential requires courage, cooperation, and long-term vision. It means investing in science, technology, and education, but also embracing ethical values that allow us to use these advances responsibly. Every step we take towards sustainability, equality, and space exploration is proof that we are determined not to be just passive spectators in the universe. Leave your opinion in the comments. Do you believe we can overcome our backwardness and join the club of advanced civilizations? This question is not just rhetorical. It requires each of us to reflect on our role in the history of humanity. We are faced with a unique opportunity to transform our legacy of conflict and destruction into a future of progress and harmony. But this will only be possible if we work together as a united species, rather than divided by artificial borders and selfish interests. Subscribe and turn on notifications to continue exploring mysteries like this. This is just the beginning of a journey that challenges us to think beyond our limitations and dream of a better future. Together, we can delve into questions that expand our understanding of the cosmos and who we truly are. Each new chapter brings new possibilities, new reflections, and new ways of seeing the world around us. Share this video, and let's reflect together on the future of humanity in the cosmos. After all, perhaps the greatest achievement we can achieve is not traveling between stars, but learning to coexist peacefully here on Earth. Be part of this search for knowledge and transformation. Our time is now.